Này thực ra là thầy đang muốn cho cái kiểu như cái chỉ thôi để chỉ đánh đó. Đấy, ok, em ngồi em nói đi.
Hello everyone. Today I will be presenting about the topic that the simulation of ofdm system on a multipath fading channel using zero forcing equalizer and minimum mean square error. This is our team member. I'm the first person, and next is Trần Bá Châu, Trần Đỗ Minh, Lê Thanh Nam. So let's get into the content. First thing we'll be talking about is the introduction of ofdm. Second, we'll be discussing the system description. Third will be the evaluation of the code. Four, we will be discussing what we have done in this topic, and four is the conclusion. So about the project, the ofdm, which is orthogonal frequency division multiplexing, is a widely used multi-carrier communication technique implemented in modern systems such as 4G DSL Wi-Fi. It employs a large number of orthogonal subcarrier to transmit data in parallel stream, so that it will be reducing the symbol rate for a given data rate and bandwidth. Next, the key feature of ofdm, which is the high spectral efficiency, by utilizing the orthogonal subcarriers, ofdm minimize the intercarrier interference. Next is the guard interval by inserting a cyclic prefix, reducing the intersymbol interference. ofdm can adapt to different modulation scheme like BPSK, BSK 16 quam, and etc. The advantage of this ofdm is that it has high spectral efficiency, robustness to multipath fading, efficient implementation using FFT algorithm. This disadvantage of this is the sensitivity to Doppler shift and frequency synchronization error, and high peak-to-peak power ratio. Next, we'll be discussing the system description. By looking at this system, we will be dividing it into many parts. First, the binary data will be going to a 0-2 parallel shifter to divide into parallel blocks. Next, we'll be going to the constellation mapping, which is to map the bit symbol using modulation scheme. Next, it will go through the IFFD blocks to convert from the frequency domain to time domain. Next, it will go to the parallel zero lifter to rearrange into zero. Next, we'll be adding the cyclic prefix extension for combat the ISI. After that, that will go to a channel transmission, going to a multipath fading channel with so that it will add the white Gaussian noise. Next, we will removing the cyclic prefix. After that, we then convert. We will input the data into a zero parallel for FFT to convert from time domain back to the frequency domain. Next is the channel equalization. I will be using the LS least square estimation with equalization zero crossing or MMSA. After that, we will emulate the stream back into the original data and go to another parallel to zero shifter. So next to the channel modeling, the input signal will be denoted at X and the channel response will be GN, noise will be WN, and output signal, which is the corrupt signal with the Gaussian noise. The relationship will be described as YN equal to XN ticked up convolution GN plus the white noise. And this is the channel estimation. As you have known, the convolution in the time domain will be multiplied in the frequency domain. By using this, we can compute the frequency response for this channel. After that, we can use equalization technique like zero forcing, which is only the invert matrix of the response, basic response. Next is the equalization technique, MLSA. By minimizing error using considering both the channel response and the noise variance. The description is on the below. This is the power to calculate the for the channel estimation, which is block type pilot or cone type pilot. Next is the evaluation. We have the simulation setup, channel model, modulation scheme, equalization, and performance metric. This is BER and SNR. This is the key results. So what have we achieved in this topic? First is the implementation, which is the develop MATLAB script to simulate ofdm transmission over multiband fading channel.
So can you can start it already? So I have a question. So you have to do the work, right? Okay. So my question is, yeah, so and so the ways that's for the obtained by the and when which are obtained by yeah, but it's really So one is better, it's better, so better, it's better.
Nó trộn hơn nữa, trộn hơn với cả cái
So can you show, because here you have a 0.3 and the other one you have a 0.4. So how I can distinguish?
có nhiều đường hơn đấy, kiểu có nhiều đường hơn, có nhiều có ra đường nhiều hơn.
So I don't think so because that's not so. If you want to compare it to so number so how about me? Yeah, so you know which is the level of the molecule that we are using for this situation. So this
Cái này em để 40, có một cái là bao nhiêu ấy? Cái bên kia là 40, cái kia là 20.
Is that correct? Có đi không một tức là bốn này không lấy không đây. Đi một không là bốn các bạn. And question on that, yeah. So if we chat at last, you are using configuration. We chat at last configuration. Yeah, but with pump to pump, you have a shadow, shadow, and candidate. So can you show me more detail about the shadow that we use for integration?
Đây cơ.
Is any question, any some question?
Nhưng em dùng Rayline sao nó chả nhiều. Dạ. Em dùng Rayline không có truyền thẳng, nên là nó đa đường. Có cái bên kia là 120, còn cái kia là bao nhiêu? 4 ạ. Là số lượng đường ấy. Cái có con mèo là 120, còn cái bên kia là 4. Dạ. Em muốn em muốn nếu mà nó có nhiều kênh, nó có nhiều đa đường thì bit nó có thể
So you want to compare same channels. So you have each. So I think so version has four. So I think actually for the content of the content of the project is sufficient to validate. However, I don't think that's excellent. Because first of all, you are registered to work with manual, right? Or you work with ofdm. Like a small challenge.
Em cũng có một file memo nhưng mà nó đọc dữ liệu ảnh mà nó đi qua nhiều loop quá nên nó không process được.
Yeah, I know, I understand. And everything you want is having trouble. Not easy, right? So you need to I mean, ofdm is okay, but ofdm is more or lower. Because actually it's more easier. The first thing, the second thing that you compare it to the same condition. Okay. So I think you need to solve it again. Yeah. About the same condition of channel. So if you can solve me a Bible, then I can English or
Right. Well,
okay, since okay. So thank you very much. So for the next, I think I think I check also the report. The report you accept is acceptable. So yeah, we will that question. Yes, it's acceptable. So I think it's not. I so can you go to the next group?
So who is the next group? Student. You just send me the slide. You can upload in the team. I can download for you. It's okay, no problem. Yeah, but you please send me your slides. I download for you. Yeah, you just upload to the team. It's okay. It's okay. Yeah, you can present. Yeah. Please upload to the team. Yeah. It's okay, but if you are discuss and present in English, you have a bonus. So if you are discuss in Vietnamese, so you don't have a bonus. So officially, we need to talk in English. So if you have a trouble or difficulties, then you can try to talk in Vietnamese. So did you send to me? Hurry up, please. Student, hurry up, please. I can for you. I can present for you. I can open slide for you. Yeah. Yeah. Okay, so we are moving. Yeah, you are a group of 7, right? Okay, so let me have you to open the slide. Yeah. Oh, yeah, I think you can now. You can start.
Bạn ngồi đây tại vì đây đang để nói với em chọn.
So good afternoon, everyone. Today I will present our group project, which is implement an ofdm system on a fading channel using the zero forcing channel equalization method. So here is 3 members of my group, we, me, and Tu. Firstly, here is a table of contents. We divided our project into 5 main parts. So let's come to the first part, which is system overview. Here we have 8 blocks. The first, the data, which is yes. Okay. Which is the data which can also be input signal, and after the QPSK modulation, it will become the digital signal, and this signal will go to the ofdm modulation and go through the Rayleigh fading channel and AWGN channel, and after that, the signal will be into the zero forcing equalization, and the ofdm demodulation and QPSK demodulation to recover the initial signal. So firstly, let's go through the multi-carrier modulation. The multi-carrier modulation technique means the entire system band is divided into many subbands with different subcarriers for each subband, and there are some advantage of multi-carrier modulation compared to single carrier modulation, which as the first, the signal interference caused by the transmission delay affects only a small number of signal samples. And the second is the system quality is less affected by multipass diversity effect. But this method has a disadvantage, which is the system is sensitive to the time selectivity of the channel, and this is because the length of signal sample increase, the time variance of the radio can occur in a signal sample, and that's why the OFDM is born to increase the spectrum efficiency. You can see here in the difference between single carrier modulation, multi-carrier modulation, and OFDM. And you can see that when using OFDM, we can save up a lot of bandwidth due to the orthogonality. Yeah. So let's come to the OFDM architecture. Firstly, the input will will go to the serial to parallel conversion, which is it separate our initial input into many parallel uh, parallel input, and then it come to the modulation. The IFFT will convert the input in time domain to frequency domain, and we have here the gap interval injection to remove the ICI. ICI, yes. So ICI. So here the acyclic prefix. Uh, this will help me. This will help to remove ISI. And the below part is used to the demodulation. Let's come to a Rayleigh fading channel. I think this part we already study in the course of fundamental of wireless communication. So I think everyone know this one. So the next part is the zero forcing equalization. The idea of this is to estimate the transmitted signal by inverting the channel metric, and in this algorithm, we consider that the noise is nearly zero to calculate the input and output based on the impulse response. So the advantage of this method is it is really simple to implement, because we just only have to find the magic of inverse of the impulse response. But the disadvantage of this algorithm is that it can amplify noise, especially in SNR in low SNR condition. So here is the flowchart of our roof simulation. Firstly, we generate random binary data. After that, we apply QPSK modulation, and then we perform ofdm modulation with 128 subcarriers. After that, we pass through Rayleigh fading channel and add noise and apply zero forcing equalization. The following step is perform ofdm and QPSK demodulation, and finally we calculate the BER and compare with theoretical values. So finally, here's our result with the table BER versus SNR.
Thank you very much. So I okay. So can you what about me yourself? Can you tell me about what you find a channel, very large channel? Is there any multi-path proposal or you multi-path proposal? There is multi-path or not, or is that only one, that is only very large channel? Is that multi-path proposal? Tức là có thì how many parts did you use? Tức là bằng nếu các em đi học phát được bao nhiêu part?
Bài gì?
Okay, can you answer this question? Any how many question? Quyền trả lời không? Em là phạm master. Rất là chính. Xin mời anh đây là cái bậc kênh của các em là học nhé. Cái này chắc là phải tìm hiểu cho thầy nhé. Đây là cái báo cáo là những chữ liên thông để nguyên trạng là chỉ có chủ đề qua. Đấy, nếu mà không làm được gì cả thì đến vậy thì thầy đấy còn channel chưa nắm được, kênh thì chưa nắm được, đúng không? Thứ hai là compare to the I think the topic is the same, but compare to the delivered team, then you work only on the perceived, and the other one they work also on the scale, so they're working more higher behind them. Anh know. Cả hai có thì thay đổi. Trên không bị nhưng mà đều chưa làm mạnh, đúng không? Phần kênh thì phải làm sao thì bây giờ chưa làm được rõ. Đấy, xem nhỉ, phần kênh chưa làm được rõ. Thứ hai là chưa mới chỉ là một số hoạt động, đúng không? Còn đấy thì là nói chung là điểm này là nó chỉ đâu đó, nếu mà để nguyên cái này là 6 cộng. Điểm phải chưa phải điểm tốt, nên là phải làm tiếp nhá. Nếu làm tiếp thì làm tiếp báo cáo thì có thông tin là sẽ thể trách trên lý hỏi này, nếu cần phải hỏi lại có hiểu theo. Ví dụ như là nếu mà làm hai môn thì phải cho như vậy, còn nếu mà chỉ giải quyết những vấn đề hoặc nhỏ nhỏ mà trong cái này học tốt báo cáo nó sẽ có nghe điểm này. Let's go please.
So we move to the next group, please. Let me. So you are group number 7. Yeah. Okay. Next group, please. Yeah. So send me your slides. Did you? Yeah. Okay. So this one, right? Is that correct? This one. What now? Okay, thank you very much.
So, hello everyone, my name is Nam and this is Việt and today I'm going to talk about the OFDM system on a fading channel using MMSE channel estimations. And first, I will start my presentations with the introductions to OFDM. So, I must mention about the our system, which is frequency divisions multiplexing. FDM, this is a technique that combines multi-channels with different bandwidth into a single bandwidth for transition over a medium. And each channel is modulated with its unique carrier frequency, ensuring no overlap between them. And about the OFDM, there are key features about the better system. There is a larger number of closely spaced orthogonal carriers are used to carry data on parallel stream, and there are also lower symbol rates while achieving the same data rate for a fixed bandwidth. It is possible to eliminate intersymbol interference, which is RSI, by inserting a guard interval due to the slow symbol rate. And about the OFDM pros and cons, about its advantages, OFDM has high spectral efficiency when compared with other spread spectral methods, robust to narrow band core channel interference, and it's also robust to SI, which I mentioned before. And it also have low implementation cost due to IFT and FT, which is inverse fast Fourier transform and fast Fourier transform efficiencies. And about its disadvantages, OFDM system have lost in efficiency due to guard interval, and it also include high peak to average power ratio, which is PREPR. And this system is also sensitive to frequency synchronizations and Doppler shift. And this is a OFDM block diagram. It will have a transmitter, and then the signal is sent to channel model, and the final is about the receiver.
So OFDM block diagram, the input is a bit stream, a parallel bit stream. So we
Our input is parallel bit stream, so series bit stream. So we convert the series to parallel, then put it into signal mapper. You kind of modulation like BBHK or M-QAM. Then we use invert fast Fourier transform to convert from frequency domain to time domain, and you cyclic prefix to cover it, then convert from parallel tree and use channel to send it. And about receiver, we just revert the process and output our series data output. This is our script about specific block in our block diagram mentioned before. Channel model we use in this project view fitting channel. So it's I would say it's an ideal channel with minimum noise, and we use some parameter like FFT and IFT size equal 128
and cyclic is about 8 or 16. This is our result. If we use PPSK, I would say it is the best modulation for transmission with noise. And this is our input image and recover image per BER about 0.072. So it's, I would say it can acceptable. And BER is increasing through the modulation QPSK and SPSK 16 quam and 32 quam, 64 quam. And we also do MMSE estimation. This theory we can call what winner filter. Know what? Minimum mean square rule. This filter widely used in wireless communication technique to estimate the channel and filter the noise. This is our result with estimation and without estimation. You can see with estimation BAR about 1.11 and without estimation is 1.32. It's quite high. Sorry. And our related work you can view file from this GitHub and some reference and some related information. Thanks for listening.
So you are
Yeah, minute be like.
now. So can so you have for MMC and DLMC, right?
Only MMSC.
So can you difference with us?
With estimation of this one. And SNR about 40 dB. It's it's quite idea. I think it in. Yeah, I know. I think it in my code, so I can decrease for.
But it's simple constellation. Look very well.
Về boy. Yeah, I know.
But the recover signal is very bad. My question is how about the channel? How about the channel? And we are feeling channel and it's a feeling, but how about the how many tech?
Only you for 8 tab maybe.
Yeah, and what's the delay of the channel?
Time delay. I have no idea.
No idea.
Yeah.
So you are the same US paper. So last project, so we need to investigate about the channel. You should know about the idea. Actually, you need to know about the channel and also the guiding cable.
That's
Guiding cable actually start.
yeah.
So because you know that I'm not sure about the final results in this condition of the signal to input back.
When I run the code, I see that it also depend on input image. With this kind of image, is quite good. With that, It's only 20 dB. Yes, I don't know. I run the same code, but the recovery image here is quite good. Yes, but I think it's about input image maybe.
The constellation does not depend on the size or the quality of the not the way not the way because the original one is very bad, but the recover I think the first result is impact. I think the simulation result is not really it's somehow is not explainable. Anyway, I the first point that you are need to go on in which you also compare with other feature.
Yeah.
The first point. Second point that check out about my question. And first point that please also investigate on the channel. Okay?
Yeah.
3 questions. Yeah. And of course, if you are staying in the program, then I don't think textbook is a big tool for you. People go online why it's for challenge. The same problem with the people project. Okay? Understand?
Yeah, really understand. Rồi máy thấy hết pin rồi.
Yeah.
Máy thấy hết pin thầy cắm sạc vào. Thầy cắm sạc vào máy thầy.
Okay.
So I think you need to the first point. Let me the first point. First question. So you are group 8, right? Student. You are group number 8. So the first point that's the simulation results. Some simulation results is not clear or it's not explainable. Yeah. Some simulation results are not explainable. First point, the channel is not unclear. Yeah. And the third point that is zero. I'm sorry. Zero forcing filter. Yeah, need to be investigated. And also it stands for the MIMO key. Okay. So I invite to the next group. Please. How about the next group?
We need to revamp again or
No. So if you have if you obtain about the MIMO results, you can present again. So if you are stay with them of them, so you just improve your results and include and revise your report, okay, and send both on the team, both on the team. Okay. So how about the next group? Next group, please. Is there anyone in our class want to present? Or do you finish now? So if you finish, then I give you a short break. So if you want to present, you can go, but send me your slides. You don't have slides? So it's better to present slide. You can present in the next time. Yeah.